So welcome everyone, good afternoon, and I'm sorry people, but that will be another talk about machine learning or artificial intelligence. But let's see if I can show you my point of view, or at least our point of view about it, and try to explain a little bit about an implementation we have chosen to do. So I'm going to bring you not to the, let's say, ground level of the network, a little bit higher up in the stacks, and maybe up to the application. So a little bit more context. Artificial intelligence. I was looking for quotes or at least definitions, and I found that one. The art of making computers that behave like the one in movies. Okay, great. That sounds like magic. Is that what? Minority Report, and I got a giant screen, transparent, and I move a finger, and then woo, all of a sudden I can predict the future. Well, let's get realistic, okay? AI is the science of making things smart, or in other words, making human tasks performed by machines. This science has broadened into many approaches: machine learning, natural language processing, speech, robotics, vision, whatever, and many techniques to implement those. And we are using them every day, from the vacuum cleaner that can do it without you anymore, to my favorite Google Translate. Well, I have to confess, I am French, so I don't speak German. All of my colleagues do, and thanks God I have Google Translate. I can just copy and paste the email, and then I get the translation. Woohoo! That saves me a lot of time. And we are all using it, that's for sure. When it comes, though, to artificial intelligence, it's about mimic the human brain. While machine learning is one of the approach we can take to mimic this human brain. And within machine learning, machine learning describes a system that can really recognize patterns by using examples rather than programming them. So this algorithm or this system will learn and will develop the knowledge so that it can give me the answer itself. When it comes to machine learning, I'm going to use data to answer questions. Pretty simple, okay? So I'm going to train the algorithm or the system because I'm going to give him inputs. I'm going to teach him and make it learn. And then ultimately, it will be providing me with a prediction of the outputs I was waiting for. And I will be also able to evaluate, giving a thumb up or a thumb down based on the output, and feed it back into the system so that the machine can learn again and the system can improve itself. That's machine learning. When it comes to machine learning, there will be multiple types of learning methodology. And the first one would be the supervised one. Let's say I'll give you a very easy example. I've got a system and I want to teach him to recognize apples. What I'm going to do, if I want to train it, first I can put an apple pictures and tell him, that's an apple. And I can repeat this step. That's an apple. This one is an apple. This one is an apple. I can also feed with pears, pineapples, orange. And at the same time, I will put the label on. So I will put the input and the output. And I will train the system. And I will repeat it multiple times. And after a while, ultimately, this system will be able to provide me with the output without me giving it to you. So I will bring a brand new input, and it will give me, well, that's an apple. Great. That's task-driven, and it's pretty accurate. It's going to be pretty accurate. But the thing is, I need the data to train my system, and I will need the labeled data. When it comes to cybersecurity or security or internet security, name it the way you want, virtual security, etc., do we have a lot of labeled data? Yeah, not really. We have tons of logs, but they're not labeled. I don't know what I want out of it. So this is where unsupervised methodology will come into play. Unsupervised methodology is when I will give the input to the machine, but I will not give the output. I will feed it with pictures of apples, pineapples, pears, more apples, etc. randomly. And after a while, the system itself will be able to group those different inputs into categories or into clusters. And when I will bring the new inputs, it will be able to say, based on the different characteristics, I pretty much think that this belongs to this group. And it will give me the output. The third method is the reinforcement learning. Reinforcement learning, some are predicting this is the future of machine learning. And it's basically teaching by not example, but it's trial and error. What is this? Look at me. What is this? A hand? No, that was an apple. Try again. So I feed back to you and say, no, thumb down, until you get the thumb up. And you have learned from your mistakes that this is an apple. That's where those type of algorithms, the reinforcement ones, are very used at the moment into the autonomous driving systems, so the autonomous cars, where the algorithm will need to adapt to a changing environment. But, okay, I'm talking about AI, I'm talking about machine learning, but what's the point about cybersecurity, or what's the point about security at all? Well, that would be not really, that should be no surprise for you, that at the moment, and we heard it this morning as well, there are threats, and we are all exposed to threats. My customers, yeah, I'm a vendor, sorry. My customers are exposed to threats, you are exposed to threats. We have a whole bunch of people outside trying to break in and come and get our data, application, whatever. We are increasing the attack surface. Yes, because we are more exposing, and everyone is exposing more information over the internet or over the outside. But at the same time, we have a lot of data we can pull some information from and we can learn from. But this data is a huge amount of data. And if anyone in this room has ever implemented an F5, I'm sure they know what I'm talking about. Our machines can be pretty chatty. So we were hearing about big data this morning, about the needs of storage that is increasing and increasing. We can fill up a SIEM platform very easily. You can log absolutely everything. Okay, I've got tons of data. What do I do with it? I have read a series of numbers, V to 0. What am I doing with data? Data is not information. Data is not knowledge. Data is it's a 0 and 1s. That if you want to act upon it, you will need to find a meaning about it. And you would then be able to put it into context and then act upon it. This is where you would need to treat or to handle or to analyze all this data. And, okay, that's good. I can do this. Well, hang on a minute. Who's going to do it? Because, you know what? There's a lot of people that are missing in our field, or at least in the security or even in the internet, in the network, I would say, field. It says by 2020, there will be 1.5 million of qualified professionals missing worldwide. Well, you know what? 2020 is just around the corner. So we do have less and less people to tackle more and more data and more threats, complex ones, sophisticated ones, hackers and so on. Well, okay, so that looks a little bit like David against Goliath, and what do I do with all this? Well, don't worry, that was the purpose of the talk this morning. Keep calm and let the AI handle it. Yeah, maybe. But for sure, what we need is to improve our capabilities. Okay? We need to improve, we need to enhance what we can do. How we can do it? Well, first of all, we can recruit more. More people is good because I will be able to do more tasks, and if I do more tasks, maybe I will find out more attacks, and I will be able to defend against them. Maybe we could include also more diversity. Okay, well, I'm just saying this. But if everyone is guarding the door, and you think that's the only way you can get into, you won't see me crawling through the window. Yeah, that's a fact. But what we can also do, and that's the main part, is to use artificial intelligence or more machine learning to solve most common tasks within data and within this field. So when I'm talking about classification, when I'm talking about data processing, this is where machine learning will help us to enhance our capabilities. So let's take a real concrete example. Okay? We, as a vendor, have decided to implement machine learning into our system. And for that, to fight against DOS. You all know what DOS is, right? DOS is a denial of service, or distributed denial of service. And guess what? When people talk about DOS, mostly what they think is this. That's a DOS. I'm filling up my pipe. What can I do about this? I'll get to the scrubbing center and that's it. I don't care about it. Well, that's one type of DOS. Yes, that's the volumetric attack. But it's not the only one. You also have what we call the known attacks. If I get blobs of water down my pipe every 2 seconds, can I get this glass of water? No. I will switch off and I will go get a bottle of water. I'm denying the service. I'm not getting access to this service. That's another denial of service. And then I have the invisible attacks. You know? Well, no magic inside this. This is just the multi-layer attacks, the layer 7 attacks. The one that looks like a perfect HTTP request, going to your server, going through each and every component of your security or your infrastructure, end up in the server, and still will crash it, denying the service. Because each and every component in your IT or in your information system has its own limitation. Fill one of these, one of the session tables, one of the CPU, use all the memory and so on, and you're facing a denial of service. So, how can machine learning help us in doing that? Can we make one of those machines, okay, that would be ours, but that could be another one, smart enough to automatically detect and ultimately maybe block these kinds of attacks? Would it be smart enough to analyze the traffic so that it can see the anomaly into it and just block that part of it, just like a human SOC analyst would do? Let's see. So yes, that's a video. I'm sorry, I'm not really fond of demo effect. I just need to... How can I launch it? That's the only part. Yes. That's it. The other way. And where's my mouse? Over there. So what you're going to be seeing is just the mechanism into action. So that's the output of it, okay? Let's see what it looks like for someone using it. And then I will explain what's the magic behind the scene. So here we have actually a system protecting a web application, okay? This is a web server. We consider the app as healthy, means that it can handle the request from the users. And we know what the traffic looks like. We know what the traffic is about. We're going to launch the attack. We're going to launch a pretty invisible attack, so high level, pretty crafted HTTP request, perfect, going straight to the server. But that's going to take down the server. So what I'm expecting is to see that, well, first of all, I need to detect it. So the system should show me that there is an issue on the server. The app is under attack. Okay, the app is under attack. When the app is under attack, I do see an anomaly. I do see the traffic peaking. I see that there is something going on. And what the system will do is it will generate an attack signatures automatically. And these attack signatures will be crafted so that it can match only the anomaly of compared to the baseline traffic that I have seen. And it's going to be automatically applied. The signatures will look like this. It's going to be samples, not samples, but a lot of parameters that if, n, that will pretty much target just the attack traffic. And while while the attack will still be ongoing, you will see that the health of the application will be reduced or will be going back to a more normal position, and the traffic will resume. So your legitimate users will still have access to the service, even though the attack is still ongoing and I'm still blocking this traffic. Okay, that's the marketing part, blah, blah. So what's behind the scene? Behind the scene is an algorithm that we have developed and implemented. There will be two algorithms. The first one is the one that's going to be looking or watching and building the baseline traffic. The second one is the one that will be evaluating the health of the application or the protected object that I have behind me. Okay? So let's look in detail at the first algorithm. The first algorithm is going to build this baseline. How I'm going to build this baseline? Well, there's not a lot of possibilities. The only thing I need to do is look at the traffic and get a picture of it. So I will look at inputs. I will look at data. And I will look at each and every packet on the wire at a certain given time. These packets, they will have certain characteristics, from layer 3 to layer 7. I can talk about the TTL, the latest octet of the source IP. I can take the destination port. I can take the URI. I can take the browser types, etc. Those are information I can find in the packets. And let's call those parameters predicates. We call them predicates. For each of these predicates, I have a finite numbers of values they can take. Let's take my example, browser types. Okay, browser types, Safari, Firefox, Google, Opera, Chrome, whatever. I have a finite number. And what the algorithm is going to do is going to classify the traffic at a certain time so that it distributes the traffic amongst all the different values for all the predicates. And at the moment, I will have, for example, a certain distribution into Chrome, another one into Opera, another one into Firefox and Safari, and so on. And I will do this for all the predicates. But if I want to get the context, if I want to get the baseline, I need to do this not only at T0, but over time. So I'm going to look at all these data every single second. So hang on a minute, you're going to tell me that I need to store all this data? What do you have? Terabytes of storage in your machines? Well, no, that's where the math comes into play. And that's where the magic or the machine learning algorithm comes into play. Because with the machine learning algorithm we've implemented, it's about to predict what would be a threshold. So what would be the next expected value for each of the predicates. So for example, if I go back and take the browser types at the given time, with a given range of inputs, small ones, I would be able, with very high accuracy, to predict the next value I'm expecting. And I will call them the threshold. And at some point, I will have the threshold set for all of the bins of the predicates, all of the different values, and all my predicates. And this threshold will be there. And they will stay, and they will be kept. And they will evolve together with the traffic. So at T0, maybe my threshold is that one for Chrome, but maybe at T1, I have more users using Chrome, and my threshold will be moving along. The algorithm is actually learning, is actually building its baseline. Yeah, okay, but if you keep on moving the threshold, how do you know that you're not learning the attack traffic? How can you decide when you are under attack? Well, that's the role of the second algorithm. And the second algorithm needs to monitor the application on the protected object that I have behind. This algorithm will need to find a way to estimate if we are under attack. And for us, the best predictive indicator, and we've given some thought about it, is the stress on the service. The stress does not mean necessarily an attack, but it means that you have a bad user experience. If you have a bad user experience, it means that you are denying the service to the user. So the service is no longer available for your user. If I can detect that there is a stress on the service, then I can start to understand that I am under DOS, or at least a denial of service. Once we reach this attack state, then the second algorithm will tell the first one, stop learning. And then we're going to check the current values. If you look at the current values here, again with my example of the browser types, well, it looks like the current value of Chrome is way ahead of the threshold. So most likely the anomaly is with Chrome or using Chrome. Okay, perfect. I'll craft the signature and I'll enforce it. Woo! If you do this, you're going to drop half of your traffic. That's not going to work. What the second algorithm is going to do as well is going to check the signature before it got enforced. It's going to check it based on another formula. It's called the similarity formula, and it will compare it to the baseline traffic. And if the overlap between the baseline traffic is more than 5%, it will get a thumb down. It will give a thumb down to the first algorithm, so that the first algorithm will get another predicate, and another one, so that it can craft the whole signature and a precise signature, a granular one, that will fit only this traffic. And when the overlap is below the 5%, we can enforce the signature and block only this traffic. Okay, pretty much I understand. But you said that we need to learn. You need the baseline. You need to start learning at a certain point. And if you are under attack, well, everything that you learn, you can just throw it to the bin. You're going to learn the bad traffic. So how do you do it? That's useless. Well, no, that would be useless if I have only one algorithm. But I have the second one. And the second one, if you're putting the system in place and the service is already under stress, it will detect it. And if it detects it, it will stop learning. It will tell the other one to stop learning. So in the end, we will not learn, we will not craft a signature, we will put other action into place, but at least we will not have learned bad traffic. So what do you think? Now it's time for questions. Please raise your hand. How many of you think that the demo I gave is an example of unsupervised machine learning? One, yes, thank you. How many of you think that I gave an example of the supervised machine learning? Maybe one. How many of you think we have a combination of both? A few more. And who think there is no machine learning involved at all and I'm just telling bullshit? Well, I think it's true. We have two algorithms. There's the first one, and it's an unsupervised statistical machine learning algorithm. This is the baseline. This is the one that is building the baseline, classifying the traffic, and predicting the outputs. The second one acts like the supervisor. But it's not really a supervised because it's not a human teaching the machine. It's another piece of software teaching the algorithm. So it gets pretty much confusing when you really want to map it to it. But you know what? I'm no mathematician. I'm just still a human engineer That's my view of the machine learning implementation that we have done. And at least I wanted to make you aware that this is concrete, and this is something that is working, and this should be happening more and more into this field. My name is Carine Polaill. I'm from F5 Network, and I thank you very much for your attention to this afternoon.
Thank you very much. Yeah.